All right, so how do robots actually use AI? It's a huge question, right? And it's not really about the crazy sci-fi stuff you see in movies. It's about something way more fundamental. We're going to break down how a robot goes from just a stream of data to, well, to intelligent action in the real world. Let's dive in. I love this quote because it just nails it. We think of AI as this big, magical brain, but for a robot, it's way more practical. It's really just about not face planting into a chair. It's this constant little feedback loop. See the thing, realize it's an obstacle, and then, change your path. The AI is just solving thousands of these tiny little problems one after another to get something done. And that's all solved using this core loop. This is basically our roadmap for this whole explainer. It all starts with sensing the world. Then the robot has to understand what it's sensing, plan what to do next, and then finally act. Now, there is this fifth step, learning, which is super important for getting better over time. But today, we're really going to zero in on those first four steps, the ones that happen in real time, every single second.
Okay, let's get into part one. From sensors to action. This is where the magic happens. How does a machine take all this messy, noisy data from its sensors and turn it into a smooth, deliberate physical movement? Let's walk through it. So it all kicks off with something called perception, and that's basically the robot's version of our own senses. This is maybe the most critical step, right? You're taking this absolute fire hose of raw data from cameras and lasers and turning it into something simple and useful. Something like, hey, that's a person over there, or, okay, looks like there's a clear path right in front of me.
And robots have way more than just eyes. I mean, sure, they've got cameras, but they also have things like LiDAR. You can think of that like a bat sonar, but with lasers, to build this super detailed 3D map of a room. They have microphones to hear what's going on, and even force sensors to feel how hard they're gripping something. The AI's job? It's to take all of these different puzzle pieces and stitch them together into one single, clear picture of what's happening.
Okay, so the robot can see things now. That's great, but that's only like half the problem. I mean, what good is seeing a shelf if you have no idea where you are in the warehouse? This is a huge fundamental challenge in robotics. You just can't use a map if you don't have a little "you are here" dot on it.
And the solution for this has this awesome name. It's called SLAM, that stands for Simultaneous Localization and Mapping. And it is exactly what it sounds like. It's this really clever process that lets a robot go into a brand new place, start building a map, and keep track of its own location on that map, all at the same time. Imagine trying to draw a map of a maze while you're still walking through it for the first time. That's SLAM. And without it, pretty much any mobile robot would just be completely and utterly lost.
All right, so once the robot knows where it is, it needs to plan. But planning isn't just one thing. It's really happening on two different levels. You've got global planning, that's the big picture, like figuring out the absolute best route to get from point A to point B. But, the real world is messy. People get in the way. That's where local planning takes over. Think of it as the robot's quick reflexes. It makes those little last-second adjustments, like, whoa, dodge that person, so it can stay on its main path without, crashing into things. And that brings us to the last piece of the puzzle, control. This quote just sums it up perfectly. Planning gives you the path, but control is what makes the robot actually move along that path smoothly without looking like a caffeinated shopping cart. It's the really low-level stuff, the physics, the engineering, that figures out the exact amount of electricity to send to each wheel to make it happen, fighting against friction and momentum the whole time.
And there you have it. That's the loop. Sense, plan, act. Sounds pretty clean, right? Well, in a lab, maybe. But the real test, the real challenge, is when you take this perfect little system and drop it into our messy, chaotic, unpredictable world. That's when things get complicated. Yeah, because here's the thing. The hardest part of robotics is not getting a robot to do something cool one time for a YouTube video. The real gut-wrenching challenge is reliability. It's about getting that robot to do a simple, boring task, but to do it thousands and thousands of times without failing. Even when the lights flicker or the floor gets wet, or some person just walks right in front of it out of nowhere.
And this is exactly why that AI brain is never just running free. It's always surrounded by what you could call safety scaffolding. These are just hard-coded, non-negotiable rules that keep it in line. The system is always asking itself things like, okay, how sure am I that's a person and not just a weird shadow? And if that confidence level drops too low, it doesn't guess. It just defaults to the safest possible action, which is usually just stopping. The whole game is about designing it to fail gracefully.
This really gets to the core of what makes robotics so different. Think about it. If an AI like ChatGPT messes up, you just get a weird sentence. No big deal. But when a robot messes up, it has physical consequences. A mistake could be a crash. It could be a dropped product. That's why trust, safety, and reliability aren't just features. They are the absolute #1 priority, period. So, okay, with all those challenges in mind, what's next? Where is all this going? Well, that core loop, sense, plan, act, that's not going anywhere. But the understand and plan parts of it, oh yeah, they are getting a huge upgrade from the same kind of AI that's behind things like chatbots. The new hotness is something called foundation models for robotics. So just like some AI models get language, these new models are trained to understand the connection between what you say, what a robot sees, and what it should do. And this is a game changer. It means we're moving away from having to program every single little task. Instead, you could just tell it in plain English, hey, can you grab the red apple from the bowl? And the robot, well, it can actually figure out how to do that on its own. But, and this is a huge but, here's the reality check. You can have the smartest AI brain in the world, one that's trained on half the internet, but that does not change the laws of physics. All those classic, reliable, frankly, kind of boring engineering systems for safety, for knowing where you are, for motor control, they are not going away. They are still absolutely essential. You can't just slap a giant AI on a robot and hope for the best. It just doesn't work that way. Which all leads us to this final, really important question. After everything we've talked about, what does it actually take to build a good robot brain? What's the real end goal? You know, in the end, a great robot brain isn't about doing backflips for a viral video. It's not about the flashy tricks at all. It's about being able to do the boring, dull, repetitive jobs with almost superhuman reliability, day in and day out without fail. That is the real revolution, and that's what's actually going to change our world. Thanks so much for joining me for this Explain.